Okay, just looking at this inequality question. So the first one, we want to prove that ABC is less than or equal to A squared plus B squared plus 2C on 4. So we're going to start with x plus y on 2 is greater than root xy. If you did have to prove this, you either need to start with this one, root x minus root y squared, which is greater than 0, and then square both of those minus 2 root x y is greater than or equal to 0 and go this way. Because sometimes you are asked to prove it. Divide by root xy, divide by 2, silly me, greater than or equal to root xy, and then that'll prove it. Or you consider left-hand sides, you have to set this out. Consider left-hand side squared minus right-hand side squared. So that would be x plus y on 2 squared minus root xy squared, which is x squared plus 2xy plus y squared on 4 minus xy, which is x squared minus, and we're going to get a common denominator, 2xy plus y squared minus 4xy on 4. So that cancels and gives you minus 2xy. So what you then have is x minus y squared on 4, which is greater than or equal to 0. So therefore left-hand side squared minus right is right-hand side squared is 0. Left-hand side squared is greater than right-hand side squared. Left-hand side will be greater than the right-hand side, which is greater than or equal to 0. Okay, so that would be true. Alright, so what we're going to just do is we're going to use that expression to prove the next thing. You weren't asked to prove that. Okay, so if you're looking at this here, root ABC is less than or equal to A squared plus B squared plus 2C on 4. I'm going to start with doing it this way. And what you do is you can use a substitution technique. So you want to prove that's greater than ABC. So if I start with this and I let my x, say, equal A squared plus B squared, and I let my y equal 2C, then if you sub it in, then you have A squared plus B squared plus 2C on 2 is greater than or equal to root x y. So x is A squared plus B squared times the 2C. So we have a little bit of an issue here that we have a 4 there. So if I divide both sides by 2, then I have created my left-hand side. So I know that this is true, okay, because I used my original expression. So what I then need to do is I need to take this and I need to show that this is actually less than root ABC. Because if I can do that, then I'll know that this is... I need to show that that is greater than root ABC, because I know that's greater than that, and if this one is greater than root ABC, then this one will be greater than root ABC. So we'll call this A, B, and C. So my whole proof is based on if A is greater than B, and B is greater than C, then A will be greater than B, will be greater than C. So A will be greater than C. Okay, so let's just consider root A squared plus B squared times 2C on 2 being greater than root ABC. And let's look at that proof. Okay, so let's consider in this proof left-hand side squared minus right-hand side squared. So that's going to be A squared plus B squared times 2C over 4 minus ABC. Because when you square the square roots, you get rid of the root. So that's going to then be 2A squared C plus 2B squared C minus 4ABC, all over 4, which is common factor of 2c, a squared plus b squared minus 2ab, all over 4, which is 2c, which is a minus b squared on 4. So this is greater than or equal to 0, because c is greater than 0, and that's a square, so that's greater than 0. So therefore, left-hand side squared minus right-hand side squared is greater than or equal to 0. So left-hand side squared is greater than or equal to right-hand side squared. So therefore, left-hand side is greater than or equal to right-hand side. We know that's greater than 0, because your A, B, C, and this stuff, they're all positive, so that's why this will work. Okay, so that means now that root a squared b squared plus 2c over 4 is greater or equal to root a squared plus b squared times 2c on 2, which is greater or equal to root abc. So make sure that you do conclude. That's a is greater or equal to b is greater or equal to c. So therefore, a squared plus b squared plus 2c over 4 is greater or equal to root abc. Proven. Okay, so we're now going to look at the second one. So with the second one, I'm just going to flip it around. We want to prove a squared plus b squared plus c squared, a plus b plus c, all over 6 is greater than or equal to root abc. Okay, so we know that a squared plus b squared plus 2c on 4 is greater than or equal to root abc. And so that means that if we rearrange this, we know that a squared plus c squared plus 2b on 4 is equal to root abc, and a squared and b squared plus c squared plus 2a on 4 is greater than or equal to root abc. So if I take each of these and I did 1 plus 2 plus 3 and add them together, then what I end up with, and I'll just put this up here, there's a little bit more space. If I add them together, I got 2a squareds. I've got a b squared and a b squared, 2b squareds, 2c, 2b, and 2a. And I also have c squareds, 2c squareds. And that is all over 4, because it has a common denominator. And on this side I have a root AB, but I have it 1, 2, 3 times. So 3 lots of root ABC. So that means you have 2 squared plus 2b squared plus 2c squared plus 2b plus 2c plus 2a all over 4, greater or equal to 3 root ABC. There's a common factor of 2 there. Two goes into that twice, and then if you divide by 3, then you'll end up with a squared plus b squared plus c squared plus a plus b plus c all over 6